Hello again. Now I just wanted to make a video on a little project that I've been working on. Now this is an Arduino Nano. It's a cheap Chinese clone of one anyway, and I've got attached to it a little infrared sensor. Now this is taken out of an old Freeview box or video recorder or DVD player or something like that. This is another one I've got here. This bit here. Now these come in two main versions. That version there, first pin is signal, next pin is 5 volt, last pin is ground. And this version here, where the first pin is signal, the middle pin is ground and the last pin is 5 volt. So when you're desoldering them from equipment, it's always best to have a look at the circuit board and try to figure out where the ground is, or else you'll have to test it afterwards and find out which way around it is. Now I had an idea that it might be good to make a volume control for my 1950s radiogram, because although I've restored the record player and got that working nicely, I haven't done anything with the valve radio, so I'm using a little transistor amplifier in its place. And it's okay, but changing the volume is a bit difficult or a bit fiddly because I have to reach around behind the back. So I thought using this and a remote control, this is off an old Freeview box, and a servo, I could get it to turn a potentiometer like this one and actually wire this in the circuit and use it as a volume control. So there's a bit of simple software on the Arduino. This is something that I've just knocked up from a couple of the examples, and I'll post some information about that as well. But just as a quick demonstration, I've programmed the Arduino to respond to the V- and V+ keys. So if I push the V+ key, you can see that the servo moves around. I push the V- key, comes back the other way. And a little servo like this should hopefully be powerful enough to drive the potentiometer. The next step is to figure out how best to join the end of the potentiometer to the servo motor. And whilst I'm tempted to 3D print a special adapter, I might just use some sort of control knob and just glue the two together, or maybe screw the two together with a few little screws, but we'll see. This is the 3D printed part. It's come out a bit bigger than I intended. It weighs about 8 grams. The hole in the middle is actually not a bad fit for this. This just about fits in, although I might open it out a bit with a file. And the other side where we've got the slot, this bit on the servo is also a bit of a tight fit, but again a little bit of trimming or filing and that should fit in quite nicely too. And then I just have to mount these two bits so that the whole thing hangs together. So I trimmed a little bit of the plastic away from the white part, just where the arms join the central circular bit. I'm not going to expand this hole here because it really is quite a snug fit on the shaft of this, plenty snug enough so that it won't turn off its own accord or turn inside the hole. And I'm also, even though I 3D printed a screw hole for a grub screw, I'm not going to bother drilling and tapping that because it's just unnecessary. I've got it mounted up now, so I've used 2 metal brackets, and the servo is cable tied on there, and the potentiometer is hot glued, and I've used the 3D printed part in the middle. So I'm still running off the breadboard and I'm still powering it via USB, although I have built a little 5-volt power board for it as well. So you can see on the meter, that's just 2 of the poles from the potentiometer. Now if I use the controller, you can see that the servo does move around, and the reading from the potentiometer changes. I've still got a little work to do on the software on the Arduino, and I intend to put on some indicator lights to show what's going on. But that's pretty much assembled. I'm going to use this little bit of strip board here to build up the circuit with the Arduino on, and the sensor here will get moved onto this little bit of board here. I'm going to use something like some 4-core cable from a USB cable to connect them together. It's finally all assembled. So I've got power coming in here. This is tapped off the 12-volt supply for the amplifier, going through a little regulator. That drives the Arduino board, which has the connector for the servo on it. So it drives the servo, drives this plastic part, 3D printed plastic part, drives the potentiometer. Output comes out here. I've tested an identical potentiometer in the circuit already, so I know that it'll be fine. The Arduino also connects here, which goes down a lump of PlayStation 2 cable, I think it was 8-core, out to the sensor board that has the infrared sensor and also a bicoloured LED. So if I grab the remote control, it flashes green and turns the potentiometer as I push the button. I've wired it up to the radiogram now, so it's connected through this cable here to the transistor amplifier which I'm using, as the valve radio in here is as yet unrestored. So I'm going to put on a record. This is an old one, nearly 100 years old, which hopefully Google won't mind too much about. So I'll put the volume up. Now put the volume down. When it gets to either end of the scale, the LED flashes red to indicate it can't go any further. Okay, that's it for now. Thanks for watching. Please have a look at some of my other videos, and if you've enjoyed this, please subscribe.